So here's our hammer. This is initial point, and we release it. It's going to just hit our sample here and go to the final position. So when it is an initial position, we have initial height with an angle. There is a potential energy here equals to mgh. M is mass, g is gravitational acceleration, which is 9.81 meter per square second, and h is initial height. So move down here, hit this, part of this, so when it start to move, based on conservation of energy, the potential energy start to convert to kinetic energy. And right here, what we have for the energy going to be half of mv squared. Means the speed of hammer, the mass of hammer, half of it, going to be our total energy here. So the hammer going to hit the sample, going to break it from here, and it goes to the final position. But the final position will be lower than initial. Why? Because part of the energy absorbed by the sample, and if you consider we don't have any friction here, which is friction almost negligible here, so if the part of energy absorbed here, this hammer doesn't have enough energy to come back to the initial height that it has at the beginning. So it's going to stop at h prime for the final height, and we are going to have here potential again equals to mg h prime this time. So the difference between this energy and this energy going to be absorbed energy. So absorbed energy going to be mgh minus mgh prime. So let's have a look to the angle. When the hammer here is at rest, there is an initial angle here, and then there's a final angle after. So, and this is our arm of the hammer that are going to be the same everywhere. If you think that they are in different length here on the board, this is because of my drawing, but as you know that this arm won't change. It's going to be fixed from here to here, all the way rotating. So, based on using R, this distance here going to be R cosine alpha, because it is adjacent to alpha. So it's going to be cosine, and the whole thing is R. So if I want to find h, in other word, h going to be R minus R cosine alpha. The whole thing minus this part going to give me h. And same thing here. The final is beta. So R cosine beta going to be this part. And the whole thing is R. So in order to find h prime, I can write down R minus R cosine beta. So in other words, this equation here, mg h minus h prime, if I substitute those two instead of that, I'm going to have this mgr cosine alpha minus cosine beta. So this is the whole thing about mathematics of IZOD impact. It works based on potential energy, kinetic energy here. This is kinetic energy, and come back to potential energy, and we could calculate absorbed energy by the sample. Now we have two types of sample. We have ductile sample, and we have brittle sample. We want to see that which one going to absorb more energy. Take a guess, and we will see later when we do the test.